Okay, so this lesson is on combination of functions, and so let's discuss what we mean by the algebra of functions. So remember the arithmetic operations are addition, subtraction, multiplication, and division. Well, when we can add two numbers, we can subtract two numbers from each other, we can multiply two numbers, and we can divide two numbers as long as the denominator is not zero in terms of the division part. We can do the same thing with functions. So for example, if we have two functions, let's say f of x, and we have another function g of x, then I can perform operations on these functions. So I can perform the operation of, let me go ahead and write this as operations. I can perform the operations of f of x plus g of x. I can combine them by adding them, and I would get a new function. I can, so that would be the adding, so sum. I could subtract them. In other words, I can say f of x minus g of x if I wanted to. Now remember, subtraction is not commutative, so the order matters. So f of x minus g of x is not the same thing as g of x minus f of x. All right, so those are two different things. Just keep that in mind for subtraction. I can also multiply them together, so I can say I'm going to multiply f of x times g of x. All right. And I can also divide them. I can say f of x divided by g of x. So remember, division is not commutative either. So f of x divided by g of x is not the same thing as g of x divided by f of x. Those are two different things. But keep in mind that addition is commutative. So if you say f of x plus g of x, that's the same thing as saying g of x plus f of x. Multiplication is also commutative. The order in which you multiply two numbers does not matter. It's the same thing for functions. So I can say g of x times f of x. All right? But the other two, subtraction and division, those are not commutative properties. They're not commutative. Okay, so that's what I mean by the algebra of functions. So given two functions, I can add them, I can subtract them from each other, I can multiply them, or I can divide them. Okay? Now here's the definition though, so this is how it's kind of going to look. Okay, so let's talk about the sum. So the directions will say something like this is parentheses, f plus g at x. So this is read as, you read this as read as f plus g at x. That's how you read this. Okay, so f plus g at x by definition is this. It's f of x plus g of x. That's what that means. So I'm going to take the function at x. I'm also going to take the function at g at x, and I'm going to add them together. Okay. Then there's the difference. So the difference looks like this. Oops. All right. So remember, I don't know if you saw this, but f plus g at x is f plus g, that's how it looks. The symbol will be f plus g in parentheses at x. So by definition, that'll be f of x plus g of x. So the difference looks like this. So it's going to say f minus g at x. So notice the f is first. The function f is first, and the function g is second. And so you're subtracting g from x. By definition, just like we talked about this would be f of x minus g of x. So that's what that means. Now, I want you to notice something. So remember, subtraction is not commutative. So subtraction is not commutative. So if you put g first, and then this right here, g minus f at x, then you would have to say g of x minus f of x. All right, remember, this function up here is not going to be the same thing as this one. The third one is multiplication. Multiplication. So if you have f times g at x, remember f times g at x, then that's going to equal f of x times g of x. All right, and then that's the same thing as saying g times f at x. It would be the same expression. Number 4, division. If you have f divided by g at x, just like this, then that would be f of x divided by g of x. Right? And you could also have g divided by f at x, then that would be g of x divided by f of x. Okay? All right, but that is the sum. Sum is where you have something like f plus g in parentheses at x, so you expand it to be, by definition, f of x plus g of x. You have the two functions. The difference, f minus g at x, would be g minus f at x. R g minus f of x. So f minus g would be f of x minus g of x. G minus f would be g of x minus f of x. Notice the first function listed goes first. The second function listed goes second in terms of subtraction. And then for division, the numerator, the function in the numerator stays in the numerator. The function in the denominator stays in the denominator. And multiplication, f times g at x is just f of x times g of x. But if you want to multiply g of x, if you want to say g of x times f of x, that's fine because multiplication is commutative. All right, so let's look at some problems dealing with this. Okay, so let's suppose you wanted to find this. So let's suppose that number one, f of x is 2x minus 1, and g of x is 3x plus 2. All right, let's suppose we had that. And let's suppose part A is you want to find this. So we want to find this. Find f plus g at x. So that's what that's how it's going to look. You will have this. All right, you have to know the definition. The definition says, well, that's going to be f of x plus g of x. That's what that's going to be. So f of x plus g of x. And so all you do is just find your function. So this says I take f of x. Now f of x is this right here. So that's 2x minus 1. And I'm going to add it to g of x, which is this, 3x plus 2. All right, and so then when I combine like terms, 2x and 3x is 5x, a negative 1 and a positive 2 is a positive 1. And so there's your answer. So f plus g at x is just 5x plus 1. Okay? So basically you just use the definition. So you say f of x plus g of x, you have your two functions, you add them up, combine like terms. All right, the b, suppose you had f minus g at x. All right, so f minus g at x. Well, again, you got to use the definition first. So the definition says that is just f of x minus g of x. That's what that is. So f of x is this right here. That's 2x minus 1. Now be careful here. See here, I did not need parentheses at all because I was just adding the two functions. But here I'm subtracting g of x. So you got to say minus, and in parentheses you got to put g of x. All right, so remember, with subtraction you have to be very careful. See, if you didn't put parentheses, if you did not put parentheses, you would be saying 2x minus 1 minus 3x plus 2, which is incorrect. Because when you distribute, this now becomes 2x minus 1. When you distribute the negative 1, that becomes minus 3x and then minus 2. So you do have to be careful. So remember, when you subtract the function, remember the difference quotient when you said minus f of x, you put f of x in parentheses? Same thing here. So just like the difference quotient, when you put f of x in parentheses, you do the same thing here, because this is a binomial. So if it has more than one term, you need to put that in parentheses, and then distribute the negative 1. And now combine like terms, 2x minus 3x is a negative x, a negative 1 and a negative 2 is a negative 3. So there's your answer. So f of f minus g at x is just negative x minus 3. Okay? Now C, suppose you had this. Suppose you had g minus f at x. Suppose you had that. G minus f at x. Well, so by definition, that is g of x minus f of x. That's what that is. And so g of x, I already know what g of x is. It's 3x plus 2. But again, you're dealing with subtraction, so you got to be careful. So you got to put that in parentheses. So f of x is 2x minus 1 this time. And then I get rid of the parentheses, I distribute, and I get 3x plus 2 minus 2x plus 1. So a negative 1 times 2x is a negative 2x, and a negative 1 times a negative 1 is a positive 1. And now combine like terms, 3x minus 2x is x, and then 2 and 1 is 3. All right, so I get x plus 3. All right. So notice when we did this, see f of f minus g, is not the same as g minus f. See, those are two different expressions. Okay? All right, now, what about if you had this? Let's say d. So let's say d, you had f times g at x. So f times g at x. Well, again, by definition, remember your definition. So by definition, that means f of x times g of x. So we're going to say f of x is going to equal f of x times g of x. And now, this time you're multiplying. So since I'm multiplying, notice how I'm going to do this. It's very important you do this. See, these are binomials, so you got to multiply these two binomials together. So I want to give you a full warning here. That's where you can use the FOIL method, because you're going to write it like this. You're going to say f of x is 2x minus 1 times all of g of x, which is 3x plus 2. All right, so notice how it's supposed to look. You got to put that in parentheses. So you got to put those functions in parentheses. So right now you know this. You know that when you add them, you don't need to put them in parentheses. You can if you want to. I mean, you could have, I want you to see this. You could have said 2x minus 1 plus 3x plus 2. You could have done that. You could have put it in parentheses. But then you get rid of the parentheses. That's just a 1 right here. And 1 times all of this is 2x minus 1 plus. And that's a 1 here. When you distribute the 1, you get 3x plus 2. So you get the same thing that we did here. Okay? Here, you could have put parentheses around this one as well. I'm just telling you, though, you need it around g of x when you subtract. So when you subtract, you do need it. But if you want to just get in the habit of putting parentheses, you can. There's nothing wrong with that. So notice what happens if you do that. Right here, you would have said 2x minus 1 minus 3x plus 2. See, I put f of x in parentheses, and I put g of x in parentheses. Okay? Now, let's get rid of the parentheses. So that's a 1. 1 times 2x minus 1 is 2x minus 1. I'm going to distribute here. I get minus 3x minus 2. And that's what we got here. See? Over here, if you want to, again, put parentheses. Put parentheses here. It doesn't matter. It matters, though, when you subtract. When you subtract, it does matter. So you're going to have, remember we had g of x minus f of x. So if I put parentheses here, that's going to be 3x plus 2 minus in parentheses here, 2x minus 1. And remember, that's a 1 right here, so 1 times 3x plus 2 is still 3x plus 2. And then distribute, you get minus 2x plus 1, which is what this was. Okay? Now, I'm telling you now, though, that for multiplication, you got to use parentheses. You have to use parentheses. So just if you need to, just get in the habit of putting parentheses around all your functions. So f of x times g of x, notice how you're going to multiply this. So that's going to involve the FOIL method, because you have a binomial times a binomial. So 2x times 3x is 6x squared. The outer is 4x. The inner is a negative 3x. And the last is a negative 2. All right, so that's what you get. So 6x squared plus 4x minus 3x minus 2. So first, outer, inner, last. Combine like terms, I get 6x squared plus x minus 2. And so that's your answer. So f times g at x is 6x squared plus x minus 2. So that's what you get. All right? Okay, now E, I want you to notice something. Without actually working out, suppose you had this. Suppose you had g times f at x. By definition, that would be g of x times f of x, right? And then g of x is just 3x plus 2. And then f of x is just 2x minus 1. I want you to notice something. What do you think the answer is? What do you think this is? Well, this should be the same thing as this one, right? Because this, you have 2x minus 1 times 3x plus 2. This 3x plus 2 is listed first, but it doesn't matter because multiplication is commutative. 2 times 3 is the same as 3 times 2. It does not matter. So the answer here is the same as this one. So it would be 6x squared plus x minus 2. All right, so just keep that in mind. All right, now f, suppose you had f divided by g at x. So f divided by g at x. Okay, if you want to get, now some of you right now are probably saying, I'm going to use parentheses just to be on the safe side. Okay, that's no big deal. Use parentheses if you need to. But use the definition first. So this is f of x divided by g of x, right? And so f of x is my numerator. Well, f of x, remember, is 2x minus 1 And some of you are going to say, I'm going to put that in parentheses. Okay, go ahead and put it in parentheses. And then g of x is 3x plus 2. But then you got to get rid of the parentheses, all right? So you can't just leave them there. You have to get rid of them. So 1, that's a 1 and that's a 1. So 1 times all of this is still 2x minus 1. And 1 times all of this is still 3x plus 2. And there's your answer. So f divided by g at x, that's how you read this. So you read it as f divided by g at x. So f divided by g divided by g at x is f of x divided by g of x. So that's 2x minus 1 divided by 3x plus 2. And if you had, let's say you had g divided by f at x, then by definition that's g of x divided by f of x, but that's just 3x plus 2 divided by 2x minus 1. Now notice those are not the same function. See, those are different function. Remember, 3 divided by 2 is not the same as 2 divided by 3. All right, so those are not the same. Those are different functions. All right, so that was that one. Let's see. Okay, so let's look at this example. Suppose we had this in this number 2. Suppose we had f of x, let's say, is 2x, let's say 3x. Let's say 3x plus 2, and g of x is, let's say 3 minus 2x squared. Okay? All right, let's say we had that. All right, so number 1, let's say A. A part, you want to find g plus f at x. All right, now remember, g is listed first. Now, this is addition, so it really doesn't matter, right? Because addition is commutative. But let's use the definition. If g is listed first, you write it first. So remember, this is read as g plus f at x. So by definition, g plus f at x is g of x plus f of x. Okay? Now, g of x is this right here. So that's 3 minus 2x plus f of x, which is 3x plus 2. Now, I did not need parentheses here because I'm adding those two. So if I put parentheses and I remove them, I still get the same thing. So I don't need parentheses here. But I do need to combine like terms, and let's put in descending order. So a negative 2x and a positive 3x is x. A positive 3 and a positive 2 is a positive 5. So in the blank, you would put x plus 5. Okay? Letter B. All right, letter B, suppose you had g minus f at x. So g minus f at x. Now remember that in that case you are going to need parentheses for the subtraction part. So g minus f by definition is g of x minus f of x. So g of x is this right here. So that's this g function. So that's 3 minus 2x squared. I don't need parentheses there because when I remove it, I still get the same thing. But I do need parentheses here because I'm subtracting all of f of x. F of x is this binomial, so I'm subtracting a 3x. I'm also subtracting a 2. So you need to put that in parentheses. That is important. So now if I distribute, notice I get 3 minus 2x squared minus 3x minus 2. See, if you had not put that in parentheses, you probably would still have a positive 2 here. So you got to be careful. And now combining like terms and putting descending order, I get, I forgot a 2x squared here, so I messed up right here. Before I go on, I messed up right here. That's minus 2x squared, so excuse me. Combine like terms, I get a negative 2x squared plus 3x, and then 3 and 2 is 5. I just realized that I did not put the x squared. So you got to be careful. If you're not careful, you're going to forget about all these little parts right here. So that's the answer for that. So the answer for this would be negative 2x squared plus 3x plus 5. Okay. So over here, when I combine like terms, I'm going to get negative 2x squared. The only terms I can combine are these constants. No other terms are alike. So I'm going to get negative 2x squared minus 3x. At 3 and a negative 2 is a positive 1. And so that's going to be the answer there. So that's going to be negative 2x squared minus 3x plus 1. Okay, and then let's suppose you want to find, let's say C, you want to find g times f at x. g times f of x. Well, by definition, that's g of x times f of x. Now, yeah, I am going to need parentheses around those because I'm multiplying them, so that's going to be important. So g of x is 3 minus 2x squared. F of x is 3x plus 2. And then notice that's a binomial. I'm multiplying them together, so I'm going to use the FOIL method. So 3 times 3x is 9x. The outer, 3 times a positive 2 is a positive 6. The inner, a negative 2x squared times a positive 3x squared is what you have. A negative 2x squared times a positive 3x. A negative 2 times a positive 3 is a negative 6. X squared times x is x cubed. So that's plus, minus, let's see. Okay, so that would be minus 6x cubed. And then the last, a negative 2x squared times a positive 2, which you have. A negative 2x squared times a positive 2 is a negative 4x squared. So minus 4x squared. Now combine like terms. If you notice, none of these terms are alike. But let's go ahead and put in descending order. So I'm going to write x cubed first. It'll be negative 6x cubed, then minus 4x squared, then plus 9x plus 6. All right, so that'll be the answer there. So negative 6x cubed minus 4x squared plus 9x plus 6. And then let's say D, you wanted to, let's say f divided by g. F of x divided by g. So D. So you want to find f divided by g at x. So that's going to be f of x divided by g of x. All right, so f of x divided by g of x. And so that's going to be f of x, remember, is 3x plus 2. So it's going to be 3x plus 2 divided by, and then g of x is this right here. So that's 3 minus 2x squared. And there's your answer. You can't do anything else. So that's your answer there. All right. So that was number 2. All right, let's suppose in number 3 you had this. In number 3. Okay, number 3, let's suppose you had f of x is x plus 3, and g of x is 2x squared minus 3x minus 1. All right, let's say we had that. All right, and let's say part A, you want to find g plus f at x. So that's how it's going to look. It's going to look like g plus f of x. You have to know that you have to use a definition. So by definition, that's the same thing as saying g of x plus f of x. Now, since I'm adding, I don't need to put any of these in parentheses, because if you do, like if you put this in parentheses here, you can have to remove it. You get the same thing, because 1 times x plus 3 is still x plus 3. So it doesn't matter. Okay? All right, and then, so here's f of x, and this is g of x. Combine like terms and put in descending order. I'm going to get 2x squared. A positive x and a negative 3x is a negative 2x. A positive 3 and a negative 1 is a positive 2. So there's your answer there. So in the blank, you're going to put 2x squared minus 2x plus 2. All right, B. Suppose you want to find f minus g at x. So f minus g at x. All right, well, use your definition. By definition, that is going to be f of x minus g of x. Okay, so f of x minus g of x. Now, I need parentheses around here, though, because I am subtracting, so keep that in mind. I'm going to have to put all that in parentheses. But f of x I don't, because if I did, and I remove them, I still get x plus 3. All right, and over here, I got to subtract g of x. Well, g of x is 2x squared minus 3x minus 1. So 2x squared minus 3x minus 1. And now if I get rid of the parentheses, distributing a negative 1 through there, or adding the opposite, I'm going to get x plus 3 minus 2x squared. A negative 1 times a negative 3x is a positive 3x, and a negative 1 times a negative 1 is a positive 1. And then putting this in descending order, combining like terms, I'm going to get negative 2x squared, a positive x and a positive 3x is a positive 4x, a positive 3 and a positive 1 is a positive 4. All right, and so that's going to be the answer there. So that's going to be negative 2x squared plus 4x plus 4. Okay? And let's say for C, I had this though. Let's say in C, I had g minus f at x for C. So g minus f at x. Well, by definition, that is g of x minus f of x. And again, I don't need parentheses here, but I do need it here. Remember that you're subtracting this function, so you need parentheses because you're subtracting all these terms. So make sure you put that in parentheses. I don't need it here. G of x is 2x squared minus 3x minus 1. That's g of x. But I'm subtracting f of x, which remember was x plus 3. I get rid of the parentheses. I'm going to get 2x squared minus 3x minus 1 minus x, and then a negative 1 times a positive 3 is a negative 3. Combined like terms, I get 2x squared. A negative 3x and a negative x is a negative 4x. A negative 1 and a negative 3 is a negative 4. And so you're going to get 2x squared minus 4x minus 4. Okay? Now notice that these answers here are not the same. So one was g minus f, the other one was f minus g. And then notice that the only difference between those two and the ones we did earlier was that the signs are different. So f minus g and g minus f, these signs are different. Okay? All right. So they're opposite of each other. All right, D. Let's suppose in D you had this. Now be careful in D. So in D you had, let's say, f times g at x. So f times g at x. Now by definition, that's going to be f of x times g of x. That's what that means. So f of x, remember, is this binomial right here. So that's x plus 3. But you do need parentheses here. Remember that now. You do need parentheses. Times, and g of x is this trinomial. So 2x squared minus 3x minus 1. And you got to multiply this out. Now notice in the previous two problems that we did, when we got to that point, we used the FOIL method. And we used the FOIL method because we were multiplying a binomial times a binomial. But I cannot use the FOIL method here, because that's a binomial times a trinomial. So you cannot use the FOIL method. So what you got to do is use the other method that works for all of them, even this one here. So even though we used the FOIL method, we were actually using the distributive property, because you were actually saying 3 times this binomial and negative 2x squared times this binomial, which gives us all of this. So here you have to use the distributive property. And here's how you do that. You probably don't remember, but this is what you would do. You would take each term in the first parentheses and multiply by your second parentheses. In other words, take x and multiply by your second parentheses. So you're distributing each term here with the second parentheses. So x times 2x squared minus 3x minus 1 plus 3, and do the same thing. 3 times this. 3 times 2x squared minus 3x minus 1. See this times this, and then plus 3 times this. Okay? So that is the same thing as this. Now distribute the x here and distribute the 3 here, which is what we get. X times 2x squared is 2x cubed. X times a negative 3x is a negative 3x squared. X times a negative 1 is a negative x. So that's what this first one is. So this x times this trinomial is this trinomial. Now I'm going to multiply all of these terms by positive 3, so I'm going to distribute the positive 3. 3 times 2x squared is a positive 6x squared. 3 times a negative 3x is a negative 9x. And then 3 times a negative 1 is a negative 3. And they combine like terms, so put in descending order. I only have one term that's an x cubed, so I'm going to rewrite it. That's this one here. But I have a negative 3x squared and a positive 6x squared, which combined gives me a 3x squared. I have a negative x and a negative 9x, which gives me a negative 10x. And then the only thing left is this constant, so minus 3. So that's your answer. So f times g at x is 2x cubed plus 3x squared minus 10x minus 3. Okay, that's what that equals. But notice that in this case, you couldn't use the FOIL. You had to use the distributive property. So this times all of this, and this times all of this. All right, and then finally f. Let's say we had g divided by f had x. So g divided by f of x. By definition, that's going to be g of x divided by f of x. And g of x is this trinomial, so that's 2x squared minus 3x minus 1, and then over x plus 3. And you just leave it there. There's your answer. You're done. Okay? All right, so that is the end. I just want to make sure. Okay, so that's going to be the end of this lesson. Now remember, this lesson only dealt with combining functions, and when we combine functions, we either add the functions together, or we subtract the functions from each other, we multiply the functions, or we divide them. And that's what this lesson is about. Okay, that's to include this lesson.